Welcome to our channel Quaint. In today's video, we are going to explore critical temperature. Critical temperature in the context of superconductivity. You know superconductivity. In case of superconductivity, the electrical resistance of the material becomes zero. Okay, so that is called superconductivity, and critical temperature, this term is involved in case of superconductivity. So what is critical temperature? Critical temperature is the temperature below which a material becomes superconductor. Yes, that is known as critical temperature. And normally, this temperature is near to absolute zero. Such as for mercury, this temperature is 4.2 Kelvin. So you know 4.2 Kelvin, this temperature is very near to absolute zero. Again, certain materials are there where such as certain ceramic materials are there for which this critical temperature is above 100 Kelvin. Okay, so anyway, so critical temperature is what? Critical temperature is the temperature below which a material loses all its electrical resistance and becomes a perfect conductor. So what happens actually in this case? Below the critical temperature, what happens? Something else must happen, and that's why it becomes a superconductor. Okay, so what happens actually? Electrons, they interact with the lattice vibrations of the material. Okay, electrons interact with the lattice vibrations of the material, and they form Cooper pairs, and the Cooper pairs move in harmony inside the material. That means they do not encounter collisions, for which actually due to the collisions, energy losses are there. Okay, so during the movement of Cooper pairs, there is no collision actually. So that's why there is no energy loss, and since there is no energy loss, that's why there is no electrical resistance. So electrical resistance becomes zero. Okay, so this is the reason behind that critical temperature, because this phenomenon occurs below that temperature, means below that critical temperature, but for different materials, these critical temperatures are different. I've already mentioned for mercury it is 4.2 Kelvin, but for some certain ceramic materials, this temperature is above 100 Kelvin. And if you talk about the application, yes, superconductors have applications in various fields like MRI, magnetic resonance imaging, in medical imaging, that is a kind of medical imaging, MRI. Okay, you might have heard this name, MRI. Then in case of experimental quantum computers, this is used, superconductors are used. Again, in case of maglev superconductors are used. So various applications are there. And scientists are trying to discover materials with high critical temperature. What is the reason? Because for maintaining ultra cold temperatures such as 4.2 Kelvin, okay, for maintaining ultra cold temperatures, this is actually energy intensive and highly expensive. Okay, so to avoid this thing, to overcome these challenges, scientists are trying to discover new materials, or they are searching for new materials which can exhibit the property of superconductivity at room temperature, means at higher temperature. Okay. Anyway, so this was all about the topic critical temperature in the context of superconductivity. So actually what happens here, above the critical temperature and below the critical temperature. Above the critical temperature, resistance is there, a positive resistance is there. But below the critical temperature, the resistance, means I am talking about electrical resistance, it becomes zero. So we can say that, and in case of zero electrical resistance, there is no energy loss. And in case of a positive electrical resistance, which is which you will get above the critical temperature, in that case energy dissipation is there. So we can say this way also that this critical temperature, this is what actually this is a transition from a chaotic state of energy dissipation to a perfectly ordered state of no energy loss. We can also say this way, means we can say the same thing this way, or this is the one way of explaining the same thing. Anyway, so this was all about the topic critical temperature in the context of superconductivity. Okay, so this is the end of this video. Thank you for watching this video.